Awesome. So our next talk is Docker, Swarm, and Kubernetes. Our next presenters are Sam and Andrea. Yep. And an interesting fact is that Andrea reports to Sam, so this is the first talk I've ever seen where your boss makes you present with them. With that, let's give a warm round of applause for Docker and Kubernetes.
Thank you. Thank you very much. Can you hear me okay? Yep. All right, let's go. So thank you, Kelsey. We're going to talk about Swarm and Kubernetes today. I'm here with Andrea. The reporting is not super important at Docker. Most important is that we work together, and this presentation was teamwork. Andrea is one of the main engineers working on Swarm at Docker, and I'm responsible for the core engineering. So we're going to talk to you today and show you how you can use Swarm to make your deployments of Kubernetes a little bit easier and portable across any cloud, any platform. So first of all, what is Swarm? So the concept is fairly simple. Swarm takes the Docker Remote API and put it in front of your cluster. So basically, the idea is that it acts as a proxy in front of your cluster of machine, and you can have as many Docker engine as you want, and then you have the exact same API. So for instance, if you do a Docker run, the important thing is that you can use the native Docker CLI without any change. And basically, Swarm includes a scheduler that will decide where the container should be deployed. So why would you use it? As I said, since it talks the Docker Remote API, you can use any tool, not just the Docker CLI. Any library that talks the Remote API works out of the box on Swarm. So this brings a native Docker experience in the sense that any tool that you're used to use every day on your local laptop, you can use it in front of your cluster. It works exactly the same. And it works also exactly the same on any cloud provider. So whether you run on your local machine or bare metal or AWS, it works exactly the same, or GC, obviously. And since last week, Swarm 1.0 is available and is now considered production ready. So basically, we spent pretty much the last 2 releases on stability and quality, bug fixing. We also added a couple of features that people might want to use if you run Swarm on production. And so few highlights of this release. So I don't know if you heard about Docker 1.9 that we released last week. So basically Swarm, since it kind of proxy the Docker Remote API, Swarm is also following anything we add to the Docker Remote API. So for instance, for this release, we added support for 2 major features that were being asked for a long time. The first one is support for stateful services through the Docker volumes command, and also the ability to create networks across multiple containers that sits on different hosts. So it makes the networking really easy for developers, and also for the same way on production as well. We also, with this release, we did also an interesting benchmark where we ran Swarm on 1,000 nodes, and we scheduled 30,000 containers on this cluster of machine. And we also we gathered a bunch of data, and next week we're going to release a blog post that details the benchmark itself, the kind of data we collected, and also the kind of tests that we ran. So it will be released roughly in a week. Actually, for DockerCon EU, I don't know if you heard, we have also a small event in Barcelona. Let's talk about Kubernetes. So what we're going to show in the demo is a simple way that you can use to deploy your Kubernetes cluster really quickly using Docker native tools. Exactly in the same way, whether you want to do it on GCE, AWS, or even on your local machine, and using only Docker native tools. So we didn't actually do any code for this demo. We just used Docker tools. So in this case, we'll use Compose. And also, this brings common plumbing. So for instance, if you're used to use Compose already to deploy your services, well, it works exactly the same way for this demo. So this illustrates what I just said. So on the layer below, you see all the platforms that you can use to do this. And then you have Swarm that brings kind of a portability layer for deployment and managing your clustering solutions. And then on top, you have Kubernetes Mesos, also Cloud Foundry, any clustering solution that you would use. And so for this demo, we're going to focus on Google Cloud and DigitalOcean and Kubernetes. So this is a quick diagram that explains how the demo works and what we're going to show. So I'm going to let Andrea talk about what you will see in the demo and present also the demo itself.
Cool. Awesome. Thank you, Sam. So I'm very excited to show a demo we put together recently that showcases how we can combine a bunch of Docker tools to get a Kubernetes cluster up and running in just one command, and that actually works across any provider. So the goal is to basically showcase that both Swarm and Kubernetes can actually work together. And actually, they even work better together because they're built on different principles, but actually they're complementary. So in this demo, I basically have my Docker Compose file that describes what a Kubernetes cluster is. I have a bunch of machines, well, a bunch, like I have 6 machines on 2 different clouds. So 3 of them are running on GC, and 3 others are running on DigitalOcean. And those machines are pretty, are pretty empty. There's only like the operating system, Docker on top, and then we deployed Swarm on top of that with just, again, one command to deploy Swarm. It doesn't really matter how the machines were provisioned. So it could be to a Docker machine, it could be just manually set up, it could be bare metal. It just needs to have Docker up and running. So let me switch to the video. Awesome. Cool. So here I'm connecting to the Swarm cluster. As you can see, I mentioned before, we have 6 machines. I have a few in DigitalOcean in San Francisco, or also in London, Toronto. We basically spread them apart just because we could. Like, there's no real reason to do that. So here I have my CLI talking directly to the Swarm cluster. There's nothing deployed. It's really an empty cluster for the time being, so it's a brand new cluster. And I'm going to run this one command, like Docker Compose up of the Kubernetes file. And basically, right now it's creating an overlay network using the new Docker 1.9 networking feature across all the different regions, so London, Toronto, San Francisco, and so on. And it's deploying every component one by one, and it's setting them up so they can talk to each other. And it's going to take a few seconds, but in the meantime, you can see that the containers are up and running. And I actually have here the API server with its exposed IP address, which we're going to just put in the configuration so that the kube control can actually talk to our Kubernetes cluster. OK. So now I have a Kubernetes cluster up and running. And it's still empty, but let's see what happened behind the scenes. So here we have our Kubernetes file, the Compose file, sorry, where we're describing all the dependencies. So we have, like, for instance, etcd. There's the API server. And as you can see, we're using the networking feature, so we can just say to talk to the etcd name, and it's just going to resolve to the overlay networking IP of the etcd. Same for all the other components, like the controller here is just connecting to the API server. Same for the scheduler, and finally, and that's probably the most important part, we have the kubelets. And the interesting part is that we made the kubelets actually mount the underlying engine Unix socket API. So what it means is that we have the machines, there's Docker engine on top, and then both Swarm and Kubernetes are actually using the same engine instance. So they have the same cluster view, they share the same resources and so on. We are not duplicating engines. And of course, it has to run privileged. And we have a Swarm affinity to make sure that no two kubelets get scheduled on the same machine, because that would be pointless. So cluster is empty. And so we're going to deploy something on the cluster. We'll just take the guestbook application and deploy the Redis service that we have available. So here we are creating the replication controller. And here's a typo. OK. So the replication controller just got created. Now, basically, the pods are being deployed. And during that time, so the pods are being deployed on the same machines, on the same engines that Swarm is using. So Swarm is actually watching over the engines. And eventually, we'll notice that one of the engines now has an extra container. And as you can see here, basically, Docker PS actually knows about the container that Kubernetes just deployed. And you can actually use the regular Docker CLI against that. So I can do Docker logs on the Redis deployed by Kubernetes. Or I can run pretty much any command like Docker inspect, for instance, which is going to show me like a bunch of internal things about the container. Cool. So here we have our pod, and I'm just going to remove the container. What's going to happen, since we set up a replication controller, is that Kubernetes behind the scenes will notice that the container is gone, and will just say, oh, shit, I have to deploy a new one. And eventually, my container gets redeployed automatically, and Swarm actually figures that out. And that's it. So right now, I have a one machine cluster, and that's not very useful. And as I said before, I have 6 machines. So what I can actually do is scale up Kubernetes through Swarm. So I'm just going to do a compose scale kubelet 6 proxy 6. So I also have the kube proxy. And this is going to create and spread the kubelets across the different machines. And after a while, so right now they're starting up on the other machines. And I can do like a get nodes to see all the nodes. Right now I only have 5. 1 is still coming up. It's going to take a little while. And yeah, I just scaled up Kubernetes on my Swarm cluster. Thank you.
All right, thanks, Andrea. So what you just see in this demo, quick recap. So we used Compose to deploy quickly your Kubernetes cluster by defining everything into a Compose YAML file. And then basically, as you saw, the provisioning was quick. So Compose, basically, I don't know if you're familiar with Compose, but basically, you can quickly deploy your stack using a small YAML file. So we showed that this works for a Kubernetes cluster as well. This demo, as you saw on different cloud providers, can work the same, even if you want to try locally for development. And also, we showed that it works with Kubernetes, but it could work also with any other clustering solutions, like for instance, Nomad. It would work exactly the same, or Mesos. And then quickly at the end, you had a Kubernetes cluster ready to use fairly quickly. So you'll see the code, actually the configuration that we use for this demo. It's open source. If you want to talk about that, we'll be at the Docker booth with the Swarm team later today and tomorrow. If you want to discuss about it, if you have questions, if you have suggestions or anything. Also, I wanted to say a big thank you to Patrick Riley and Kitematic for inviting us at the conference and present this talk. Thank you, Patrick. And that's it.
All right, so we do have a moment for a Q&A. I think we can take 3 or 4 questions. Do you guys have questions? Great. All right, here you guys go ahead and take Q&A.
Yep.
What use case do you see for using the Swarm API once you have Kubernetes out?
So there are many advantages. Like once it's out, you can actually continue using the Docker API to scale it out. But actually, let's say that you have your machines, you're running Swarm, which is just a very thin layer, like it doesn't do pretty much. But on top of that, you could, I don't know, deploy Nomad or deploy Mesos or whatnot and just play with them and basically use it as your layer for deploying cluster managers on top of your cluster. And also, you'd be managing a cluster manager the same way you manage an application. So it's in a container, you get to upgrade it, you get to fetch its logs through the API, and basically you manage your cluster manager like you would manage an application running on a cluster manager, if that makes sense. Okay. Good.
I don't see any. Oh, one question.
If Swarm with Docker 1.9 is using the networking to link nodes
Yeah.
from various providers or even from the same provider, does Kubernetes also some kind of a network graph where it brings the two together? Does one encapsulate another?
Yeah, so actually,
Repeat the question.
okay, so the question was about Swarm using overlay networking for the communication, and there's also Kubernetes doing the same. So are we using encapsulation, something like that? So the answer to that is that, so we got Docker networking 1.9 about a week ago, even last Tuesday. So there's already a pull request in Kubernetes to basically add support for using the lib network code. So it means that once that gets in, you can configure Kubernetes to use basically Docker networking and Swarm to do the same, so they'll be sharing the same overlay network. So you don't get to duplicate that. Not at the moment, no. No.
Using this demo, actually,
You,
Kubernetes network is encapsulated inside of lib network.
no, you actually have to deploy Weave or something like that to get your networking up and running. So in this demo, at this point, there's no networking intercontainer on the Kubernetes side, only the Swarm side, until until we can configure Kubernetes to use the Docker networking stack.
So not full-featured Kubernetes cluster.
Not at the moment, no. Not during the demo, yeah.
Yeah, we really wanted to show the deployments. So this.
It's awesome, by the way.
Yeah, thank you.
Thanks.
Yeah, we got the feedback from many people that sometimes it was taking longer to deploy Kubernetes, depending on your cloud infrastructure. And we actually saw different people saying, oh, actually we use DigitalOcean for dev, and then we use GCE when we want to move to prod. And so we thought that it was a good idea at this conference to present a quick way to deploy it.
Thank you. Thank you.
Thank you very much.